The deep sea is one of the least explored ecosystems on Earth, home to unique species we're only beginning to understand, and some that we haven't even discovered yet. We've explored what deep sea mining potential benefits may be, but we need to understand how mining operations could actually disrupt these fragile environments and potentially wipe out undiscovered species. What is going on, everyone? Welcome back to OneSwell. And today we're continuing our conversation about deep sea mining. We're gonna talk about the hidden costs, some of the risks associated with it, and we're gonna even talk about the global debate that's happening right now around the world. So in our last video, we discussed what exactly deep sea mining is, and we explored the possibility and the potential benefits that it might have for our futures. Now, some of you found out some countries or companies do believe that this is the future of our resource extraction. But as you know, not everyone agrees. Now, scientists and environmentalists all around the world are sparking debate in regards to the environmental concerns and the damaging effects that deep sea mining potentially has on our oceans today. Now, I know we talk specifically about the ocean here, but will deep sea mining also affect our climate possibly? So I've created this little experiment to showcase in a nutshell and in the simplest possible form what is happening when we refer to deep sea mining, okay? I'm gonna show this experiment from a couple different angles and a couple different ways so we could really understand what's happening. So up top here, we see the processing vessel. This is what's at the surface of the water. Now that vessel is connected to a riser shaft. That's where all the sediments and any materials being processed are fed through and up to the vessel. That riser is connected to the ROV that you see here that I tried to put together. That's the collection vessel. And for purposes of this experiment, I want you to consider all these rocks that you see here as polymetallic nodules. And that's what they're going after and what they're trying to collect to extract the metals and minerals that we need to keep up with production. What happens is this ROV crawls along the bottom of the seafloor, picking up anything in its path. Now, unfortunately, that could mean polymetallic nodules, or maybe those cobalt crusts. You'll see that in its way may be something in regards to life. Again, this ROV crawls along the bottom, scooping up and sucking in anything and everything in its path. Now, if you remember correctly, I told you that this takes place between 6,000 and 3,000 meters. Okay? And the reason that that depth ranges so greatly is because we have things like seamounts or underwater mountains and different topography that is going to change the depth at which we're working. But for purposes of this experiment, here it is again. And this is what it would look like more accurately in the conditions that are present at those depths. Another major concern with deep sea mining is the creation of sediment plumes, which occur when mining activities disturb the seabed, sending clouds of fine sediment into the water column. These plumes can spread over vast areas, potentially smothering delicate marine habitats such as coral reefs, sponge fields, and hydrothermal vent ecosystems. Many of these habitats host unique and slow-growing species that may struggle to survive under layers of sediment. Additionally, sediment plumes can reduce water clarity, affecting the ability of marine organisms to feed, navigate, and reproduce, which could have cascading effects on oceanic food chains. Now, this is the part 2 of the experiment under wet conditions to simulate actually being underwater at the depths that we spoke about. I'm going to go ahead and do the experiment and then tell you about something else that you might not have thought of that could be a potential impact on our planet based on these new deep sea mining efforts. So I just want to showcase, again, this is the homemade ROV. I now removed the flashlight, but I'm going to leave the light on in the tank so you could see it. So basically what happens is these guys come down, they land. Now right there, you could see the first type of plume that would happen, right? Just from the initial contact. Now, as it goes along the bottom, you'll see it releases more as it goes on. But it's not going to just do this one time and be done. It's going to go back and forth in that area over and over and over again until it collects all the resources that it intended to for that specific area. As you see, this coral that I have here is beginning to get smothered by the byproduct of this. But let's just say they work an area and they see that there might be more. Well, what's going to happen is they're going to go deeper. And now we're effectively destroying that habitat along the way. But let's just make it really dramatic. Let's say there are multiple vehicles trying to source this material. They're all going to be moving in different directions and in different patterns, right? This way, that way, this way, right? Now look at the tank. Look at everything floating around. Look at the surface of the water. Look at everything in between. These are the plumes that I'm trying to talk to you about. But now, let's take it a step further. And I told you we were going to talk about something you might have not even thought of that could be a possibility that comes out of this. Well, another significant issue is the potential impact on carbon storage. The deep sea floor plays a crucial role in long-term storage of carbon. As organic material slowly accumulates and becomes trapped in the sediments over millions of years, mining activities could disturb these sediments, releasing stored carbon back into the water column and potentially even into the atmosphere. This disruption could contribute to rising carbon dioxide levels, exacerbating climate change, and given the deep ocean's role as a major carbon sink, any interference with this delicate balance could have far-reaching consequences for global climate regulation in the future. So pretty wild stuff, right? Not only the initial impacts, but the long-term lasting impacts from atmospheric or climate standpoint. So we've learned that marine life, the actual ecosystems, the environment, the weather, the climate, a number of things could potentially be altered or affected by deep sea mining. So now that you've seen the experiment in dry or wet conditions and from different angles, now that you've seen plumes forming and you know what can actually happen besides those plumes, let us know down in the comments what you think. Are you for it or are you against it when it comes to deep sea mining? Hopefully I did a good enough job explaining this to you guys so you can make your own decision. I'm not here to tell you which side is right or wrong. Everyone should be entitled to formulating their own opinion. These are just some of the simple facts in regards to deep sea mining, and I thought that everyone should know about it. Now, we should talk about the economic and ethical debate of this all. So as we know, some people do see deep sea mining as the future of resource extraction, but others don't agree. And the reason they don't agree is because of what's currently happening in the world today. People believe that there are improvements and systems that can be put into place right now on existing systems to avoid the potential need of even getting into deep sea mining in the future. So let's talk about it a little bit. Now everyone here, I'm assuming, because you're watching this video, you have something that contains some of these resources that they're trying to extract. Whether it would be your phone, your computer, right? And those are just things that you're viewing things on. Now let's talk about the internals of that all. We have things like batteries and microchips and circuit boards. And we could take it even a step further and include car batteries and things along those lines, okay? Right now, we have millions and millions of tons of this stuff all over the world. But what happens when there's no longer a need or a product gets past its shelf life? Unfortunately, right now, most of these products are not properly recycled in the first place, and they just end up being in landfills and end up as e-waste. These millions and millions of tons of e-waste already have the desired resource within. So people do believe that we can find a better way to recycle and utilize these old products to repurpose and reuse the material that's within to continue future production. Now, the other side of the debate on this is that people believe that even if we can improve our systems or come up with a perfect way to harvest and utilize this e-waste, that it still won't be enough to meet future demands of these resources. One area in particular that this is a great debate is in the EV car market. These materials are insanely prominent within that industry as it goes to create all batteries, all necessary components to actually make these vehicles function. And as we know, there is a big push in the world today to go to the EV side of things and to eliminate the use of fossil fuels. Will it be enough for us to sustain in the future? Leave a comment down below and let us know what you think. So in the last video, we talked about what the ISA was, the International Seabed Authority. Now these guys, as you might already know, are the governing body that are working on the regulations in regards to deep sea mining. Now, I don't know about you, but I know that throughout history, not all companies or agencies or government may do the right thing or not. They may say they're doing one thing, but there's a potential that the overexploitation of something might also occur, right? And that goes for any industry. So, do you think that deep sea mining can actually be regulated and monitored properly? The issue with deep sea mining is that it falls into the international waters and laws category. The ocean is massive, it's vast, and it's hard to keep track of. So, because of that, we have nations that are like China and Norway that are pushing to commercialize the industry and begin profiting off of this. And then you have nations like France and Germany that want a moratorium on this. And for those of you who don't know, a moratorium is a suspension or a halt in activities related, in this case, to deep sea mining. And just so you know, a moratorium is needed because it allows the proper time for experimentation to be done to see the long-term effects of something. It doesn't allow the process to start immediately. It causes delays, which certain countries may be upset about because it takes time to start profiting. However, other countries believe it's necessary because it will leave a more protective future on the environment. Now, the good news is that many governments and organizations do support and push the idea of a moratorium. And believe it or not, you will be happy to find out some even large-scale companies that you know about and hear about every single day are also involved in pushing for proper regulation and safety for the environment when it does come to this. Some that you might have heard before are BMW, Volvo, and Renault. They have all distanced themselves from this and from deep sea mining as a whole as a way of allocating or receiving the resources that they need for future production. So that's great to hear that there are some big corporations that even realize that this might not be the move. Now, some people do believe that a compromise will be reached and that there will be a safe way to properly do this. However, the other side of the debate is that the impact that it will have for future generations to come will be too great and too damaging, and it should not be done. As you found out, people want to start this today to begin profiting, but you also found out that people are trying to stop it for the long term. So think about it. Where do you stand on deep sea mining? And if you enjoyed this content, consider liking and subscribing to OneSwell. It really helps the channel and it is greatly, greatly appreciated. And always remember, together we can make a difference one swell at a time.